3D printing is creating a silent but radical revolution in the space industry. While traditional rocket manufacturing can take years, additive manufacturing makes it possible to build rockets in a matter of weeks. Companies like Relativity Space are leading this transformation, building rockets layer by layer, almost like sculpting metal, dramatically reducing both cost and production time. At the center of this revolution are giant industrial 3D printers. Unlike desktop printers that melt plastic, rocket manufacturing systems use robotic arms with advanced metal melting technologies. Relativity Space's Stargate system, considered the world's largest metal 3D printer, melts a special aluminum alloy wire using lasers or plasma arcs, depositing molten metal layer by layer to form the rocket structure as a single integrated body. One of the biggest advantages of this approach is the massive reduction in part count. Traditional rockets are assembled from thousands of components, bolts, rivets, joints, and panels. With 3D printing, structures that once required hundreds of parts, like fuel tanks or engine sections, can now be printed as a single piece. This doesn't just speed up manufacturing, it eliminates structural weaknesses created by tie-ins and joints. At the same time, material is placed only where strength is needed, making rockets significantly lighter and more efficient. Rocket engines are one of the most powerful use cases of this technology. Inside every engine are extremely complex cooling channels that protect it from extreme heat. With conventional manufacturing, creating these internal structures can take months. With metal 3D printing, these channels can be printed directly inside the engine using technologies like selective laser melting. Rocket Lab's Rutherford engine became a historic milestone as one of the first main rocket engines produced almost entirely by 3D printing. The materials themselves are far from ordinary. Nickel-based superalloys like Inconel, copper alloys, and specially engineered aluminum blends are used in powder or wire form to withstand extreme temperature, pressure, and vibration. The entire production process is monitored by AI-powered software. Sensors and cameras inspect every layer in real time, detecting defects before they become failures, dramatically reducing human error. The result is a complete shift in rocket manufacturing. What once took 12 to 18 months can now be achieved in less than 60 days. Design changes no longer require rebuilding factories, only updating digital CAD files. 3D printers are not just building rockets. They are rewriting the rules of how humanity reaches space.